Okay, we'll continue on here on page 6. Just a little bit of a discussion, some big idea answers here that you ought to be able to explain. If two figures are similar, so we're going to do a little comparing and contrasting of our previous unit with this unit. If they are similar, are they considered congruent? That is the question. So remember, this is what we just took our test over. Remember, you could have a small triangle and a bigger triangle, and we did all these comparisons between them. They are not considered congruent. This is obvious, I would think, that these are not congruent. So I'm going to say no. You might draw a picture of a small one and a big one because sides would not be congruent. Although angles would be. Right? We do know that. And they were similar. All the angles were congruent, but the sides were not. It's just that the sides were proportional. All right? So let's answer the other way. If two figures are congruent, are they considered similar? So we need to think about this. Congruent. So if I had two, let's draw two of them that are exactly the same size. Okay. If these are congruent, then let's think about the definition of similarity. Remember, similar, all the angles had to be the same. Oh, well, if they're congruent, all the angles are going to be the same. So that part checks out. But are all the sides proportional? If they're congruent, whatever side this is, this one's the same. Whatever side that is, this one's the same. This is what we mean by congruence. So the question really becomes are those sides proportional? And by definition, yes. It's just that their multiplier is 1. So I would say the answer to this question would be yes. If they are congruent, they are considered similar. It's just a special case of similarity. It's in a 1-to-1 ratio. So say they are congruent, also similar. You might say they're in a 1-to-1 ratio out here. Okay. These theorems or these acronyms, side, 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 and side angle side, why do they work on both similarity and congruence? It's an interesting question. I would say, really, we could just say that congruence is a special case of similarity. All right, we want you to really understand that and be able to say this and why. All right. It says, let's look at the big picture about congruence versus similarity. The definition of congruence seems to be more straightforward. Why do you think we covered similarity first? Be ready to justify your response. I would say we do like covering similarity first because we can use similarity to prove congruence. And I'm going to show you that down here below. That's one of the reasons. Maybe the other reason is that similarity maybe is a little tougher, I think. It's a little harder. We did the hard one first, and we have that out of the way now. And the similarity unit doesn't have quite as many proofs. Maybe that's another reason we covered that first. But this unit is kind of proof heavy. Okay, so we should kind of know the process. I did want to show you this. I'm just going to show you the proof and talk you through it. But what it's saying is, before you just start writing something down, it says complete the proof of the side, side, side congruence theorem. So we're going to prove that side, side, side works. Now, I did it kind of informally with you on the experiments with my compass and drawing, and you saw that if I had certain side lengths, I came up with the same triangle. But how do we prove it? Right here. And what's interesting is you use similarity to prove this. Okay, so if I, maybe you can freeze the thing right there and write that down, but maybe you'll hear me out also that what's going on right here is by the way, this is congruence and equals. Some proofs will do this, just that's not really much of a difference. Sometimes I skip this step. But we just say when things are congruent, their lengths are equal. And then we compare all those lengths and we get a 1-to-1 ratio. And then we can say that all those ratios are equal to each other. And so what this is just like doing our side similarity. Notice this is similarity. So right now I can say that these triangles are similar because of side similarity. And then from there, I do know, since they're similar, I do know that all their angles are congruent. That's just a result of similar figures. So then I can turn around and say, well, then the triangles are more than similar. They're congruent because up here above, I have listed out all 6 parts to be congruent. I've got all 3 angles right here, and I was given all 3 sides up there. So that's kind of we use similarity to prove side congruence. Now, I do want you to try this proof on your own without me. This is doing the same process, but with side angle side. So I think you can read the steps right here and figure it out. And you can see halfway down here, we got some triangles are similar by side angle side. And then from here on out, we're just establishing that the other 3 parts are indeed congruent. And so I want to see if you can do that yourself. All right.